Yeah, I'm kind of interested about that because I know that in the past you have talked about Pipewire and automotive grade Linux. So,
Right.
what sort of requirements exist that don't exist in the desktop space?
Right. Yeah. So in automotive, if uh, mm, yeah, if you how do I start from that?
Well, I guess
Basically,
for as like a
in
start, just explain what automotive grade Linux is, and then we can sort of go from there.
all right, yeah, that's easier. So automotive grade Linux is a project that aims to bring automotive companies together to collaborate on common software that they use. It's clear that automotive is going to the so-called software-defined vehicles, where basically the hardware, the engine is pretty standard. Is nowadays it's just a motor and a battery. Like there is nothing, there is nothing there. All of the complex engineering that was being done for internal combustion engines is gone. So what's left, and what is the value that they bring to people? And it's mostly the software, right? And we
Mhm.
have from basic infotainment software, which has been there for a long time, actually. Things that, uh, like things like playing music or playing video on your car,
Mhm, mhm,
to very complex use cases like autopilot, like taking control of your car and doing all sorts of crazy things there.
mhm,
And all of the things in the middle, like there's a lot of lots of crazy use cases there when it comes to software.
mhm,
So automotive companies are moving to software, and in order to do that, they need to have they need to start from somewhere. They obviously use a lot of Linux on
mhm,
it, or they want to use Linux. There is also other operating systems they use that are targeted to automotive specifically.
mhm,
Um, but yeah, Linux makes a lot of sense. So they try to make a platform based on Linux.
mhm,
And automotive grade Linux is an effort still to bring all of those manufacturers together so that they can collaborate and they don't have to reinvent the wheel every time they want to build a platform.
mhm,
So they maintain a base distribution, a Linux distribution based on Yocto.
mhm,
Uh, for those of you that don't know, Yocto is an embedded Linux distribution. It's a distribution that it's basically something like Gentoo Linux. It has a set of recipes that build the software. It's not
mhm,
pre-made packages, and it's targeting embedded devices. So automotive grade Linux is a distribution that builds on top of that, and it provides basic software and configurations that make sense in a vehicle. And yeah, there are some companies, the automotive companies, that build their platforms based on that. They
mhm,
take that as a base and they build on top.
mhm.
Now, if you go to a trade show or conference and you see automotive grade Linux demos, you will see that there is a user interface as well,
Mhm.
where you can play with things and play music and see your rev uh, your engine revs
Mhm,
moving
mhm,
and things like that. Like this is a UI that is supposed to be a demo. It's not something that you can actually install in your car. It's supposed to be the thing that people will see and test with when
mhm,
they build on automotive grade Linux. But then as the actual companies who are building the car take the software, they remove that and they bring in their own
mhm,
UI and user experience.
mhm. So where we were going with this was we are talking about like Pipewire in this space. So what requirements differ when we're talking about this space? Like what are people looking for that may be different from the desktop?
Right. So typical desktop has 2 speakers and a microphone, right?
Mm.
That's the main setup. Now, in a car, you can have a lot of speakers, crazy setups, and a lot of microphones as well. Crazy numbers of microphones in all places. And there can be very, very simple use cases, like you play a music file or a stream or radio, and it plays all over your car to all the speakers. So that's nothing. That's very easy. That's basically a desktop use case. But there could be cases where you separate the car in zones. So you have something playing over here, something playing over there. You take input from the microphones and you do crazy amounts of noise cancellation and a voice isolation. So you can speak, you're on the driver's seat, you speak, you're talking on the phone, and it's only you that can hear what's going on and speak to the phone. Like there are these kind of setups in very high-end luxury cars where oh, I think I
Did
think
it
I lost you
disconnect
again.
again?
Damn. Hello?
Hello, I can hear you. Oh, Discord. What a great platform this is. Okay. Discord problems. We're on Jitsi now. So yeah, let's just keep going.
Great. So I was saying about, that the car has a lot of speakers and a lot of microphones, and there are use cases, for example, where you isolate one person and you direct the audio towards one person, and you grab the voice from that one person, and you do crazy amounts of noise cancellation to make sure that nobody else can hear what you're saying on your call, and things like that. Now, of course, we don't do all of that in software in automotive grade Linux. What we do is this is a crazy use case that very few manufacturers do, and they do a lot of hardware there as well still today. With their intention being to move the software down the road. But what we do is we have we basically have policies to differentiate between streams based on the use case of the stream. So there are streams, audio streams that are basically music or media that you're playing, and then there is another audio stream that it can be your voice assistant, navigation assistant, right? And then maybe there's another stream where you're in a call and you receive audio from that call and you're speaking on the phone. So these kind of streams need to be handled differently. If we were applying the default desktop setup, desktop policy, we would basically be routing all of them the same way, just as we do on desktop. So if you start a call on your desktop with Jitsi, Discord, whatever it is, that doesn't stop your music. That doesn't change anything on your volume levels. It doesn't do anything in particular that that recognizes the fact that you're in a call now. But in a car, there is a different policy being applied. So if you are in a call, then all your music will stop, and we will make sure that even if the application misbehaves, it won't be audible. It will be just isolated and won't go to the device. Same way for navigation assistants or voice assistants. There's another policy there that will say, okay, when the voice assistant is speaking, then if there is a music at the same time audible, we lower the volume of the music so that we can hear what the assistant is saying. These are also common things that happen on mobile phones. So the policy is not very different from what you have on your Android or iOS device. It's basically similar stuff, and there are also volume controls for each use case. So there's a volume control for multimedia, volume control for voice, volume control for calls, which is again same thing as it happens on mobile phones. So that's the main thing that is different today in automotive grade Linux versus the desktop.
So in some ways, you're less concerned about the individual audio devices, and you're more concerned about the audio contexts.
Exactly. Yeah. Yeah. This is something that could also make sense on the desktop, and actually on our last update on this functionality, we added support for being able to run this kind of policy in parallel with everything else on your desktop. So if you want to try it on your desktop, it's there. You can enable it, and you can configure your streams to have a context, and then this policy will be applied, right? And some people use it. Some people want to have a voice assistant, for example, and they want to prioritize it and duck the music. That's a common case that people ask for. And it works also on the desktop. The problem with the desktop, though, is that not all the applications will provide context of what they are, what they do. Especially web browsers are very tricky to get, to get the context, because a web browser can be playing music, it can be playing advertisements, it can be playing a video, it can be playing a call like we are doing now on ZZ. So you don't have that context, and there is no browser API to let the website give us that kind of context. So yeah, there is no way to know, and basically that's why that can't really be the default on the desktop, because we don't have enough context.
Right. Okay, that makes sense. And especially as, a lot of applications move into the browser and you realistically could do a lot of your computing just in a browser without some sort of extension to web APIs, which could possibly have some value, you can't really do much with that.
Yeah, currently we don't have the APIs, right? So there is no way we can do something. And there are websites also that might have different streams from different use cases that go out as one stream on
Right,
Pipewire.
like an ad playing and then the actual content on the page that you want to see.
Exactly, yeah. They can be the same stream as far as Pipewire is concerned. The browser can do mixing, and it can do things. It depends on the browser, of course, and it depends on how the web API is being used. But yeah, there are these kind of use cases, and there is no way you can tell what it is and isolate different streams and do anything meaningful with that.